Hi, I'm Troy Daniels, the technical trainer here at SimpliPhi Power. It's going to be a pretty short presentation. It's just a fun little one I do regarding power outages and building resiliency through distributed assets. Interestingly enough, this actually came out of some pretty big, significant weather and power outage events. I think actually the Texas outages were a big kind of contributing factor to why we put this presentation together. As you all probably know, there's some pretty severe weather going around the United States currently. So I think it's probably more than relevant currently in what's going on. So I'm just going to give a little bit of background on SimpliPhi Power, not a ton. If you want kind of like the basic 101 regarding our products, what we do as a company, I would definitely check out maybe BAT 101 or some of my other NAPCEP certified trainings. We do safe, proven, and simple technology. Safe is non-toxic, non-hazardous, cobalt-free chemistry. There's no risk of thermal runaway with fire propagation. As far as UL standards go, we meet 1642, 1973. So 1642 is cell level, 1973 is battery level, and now 9540, which is full system level. 9540A is the test protocol regarding fire safety that we've also gone through and passed. UN DOT certified 3480, 38.3. We're SGIP approved if you're in California. As far as proven technology, over a decade of experiencing growth within the energy storage, deployed in over 40 countries, over 100 megawatt hours installed worldwide. We've actually been tested and validated by the US Army and Marine Corps. We have special permission to fly from the FAA, and we're actually manufactured in the US. Simple technology, we're always trying to keep things as simple as possible. We integrate and optimize with really any generation source, grid, solar, wind, generator, on or off the grid. Huge line of products to kind of fit each different demand that you might have. And we integrate with most existing products as well. We also work with products that create things like savings through utility bills with TOU, the time of use, peak shaving, and demand charge management. So kind of a little bit about, and I think this is really relevant to this presentation, is kind of looking at, as they call it, the problem or what we're trying to overcome with our products. Escalating energy costs being one of the biggest. US residential electricity prices have risen by 15% in the last 10 years. Obviously, this trend is expected to continue. You're not going to see a lot of rates go down, if any. And you're also going to see a lot more surge charges and time of use charges being tacked on to various utility companies. European electricity prices expected to increase by 30% by 2025 as they phase out coal and nuclear plants. So again, just showing that the trend is continuing to go up. The cost range for diesel generated power in remote and island communities vary from $50 to $1 per kilowatt. So again, we're just kind of looking at how we can optimize that. That's actually really an interesting point I always like to make is, we're looking at maybe certain island communities or small communities that do use diesel generated power. The great part about a battery is it can actually be utilized to cut cost while still using that diesel generated power. So it can actually be added into that system. And now you are able to charge the batteries and be a bit more reactive with your power, actually cutting costs down and diesel consumption. Now you save, maybe if it's generator, you're saving the generator's lifespan even more. You have batteries and generator now, so you can generate your power, use it when you need to. Failing infrastructure. 2010 through 2019 marked the costliest decade on record, with economic damage due to severe weather reaching 2.98 trillion globally. Since 2003, the average annual number of weather-related power outage doubled in the US, resulting in billions of financial losses. Again, I think we're kind of reaching that time of year right now where, as far as the cold goes, we're going to see a lot more of that and a lot of these weather-related power outages. The US electrical grid is aging, with 70% of transmission lines and power transformers that are 25 years or older. Decarbonization in the US, over 150 cities, 13 states, and 7 utilities have 100% clean energy goals within a clear path to meet them. Wind farms and solar plants across the globe are causing severe fluctuations in electricity prices and power outages due to their intermittency and economic growth. Rising population, electrification of major industries means that renewables alone can't keep up with worldwide energy demands. So that's kind of just a few reasons why we do what we do. And I think it has a lot to do with this. I'll skip over this a little bit, but we're going to talk a lot about resiliency with this, but I think it's always kind of important to look at two sides of any coin when you have a battery plus solar storage, or even just a battery storage system. Really, if you're just looking at using it for resiliency, there's a lot of other applications that you can use it at the same time to kind of make it financially viable. If you have peak shaving demands or time of use rates, we can cut those out significantly, if not altogether, using a battery system and using an integrated solar plus storage system. We can actually cut that out even more while we're generating our own power as well. Okay, so now I'm going to kind of talk through a little bit about, solar without storage, solar with storage, and understanding these various kind of distributed assets, how they interact, what the advantages, what the disadvantages are here. Something I didn't mention, if you have any questions throughout the presentation, there's a Q&A little button there at the top of your screen. If you go to that control bar, type any questions in there. Again, this is a pretty short presentation, so we should have plenty of time to get around to some questions if there are any. Okay, so let's talk solar without storage. So we're talking grid-tied solar. It often comes at a very affordable price. Prices only continued really to go down, maybe a little bit up in the very recent events with kind of just looking at supply chain shortages. They often come with various financing options or leasing options and just buying outright. So definitely a little flexible is how you actually purchase these systems. Adding solar panels to a residence can often completely cut out the electricity bill. So just by adding solar, you might actually produce enough to offset your entire electricity bill. What do customers typically not understand about their grid-tied solar PV systems? I actually started in grid-tied PV, and I can definitely attest that a lot of customers are not very up to speed on what disadvantages or what features these grid-tied only systems do not have. So solar production will not work during an outage, and customer will still lose power the same as other houses without a PV system. I think that's the biggest hangup I see. A lot of customers that maybe just purchase just solar panels, all it is just a grid-tied solar array. They expect that maybe they might have some power when the grid goes down, and it's simply not the case. The solar panels will not function without grid present. Having a PV system will most likely not protect a customer from things like peak demands and time of use rates. It's just not reactive enough. And really, we're going to end up with basically just a PV system that sells back whenever it wants to, which doesn't cover those kind of demand costs. Solar production generated when loads are not active is not stored, but sold back to the grid. So you're really not using your own generation source when you have a PV only system. So obviously that brings us to solar with storage and why it makes sense. So adding a battery plus corresponding electrical equipment, such as an inverter and a charger, can greatly increase the benefits of a PV system while also providing benefits of the battery itself. So during power outages, a customer can actually utilize the battery to cover critical loads. This almost always is set up automatically. So that means like an ATS switch, an automatic transfer switch to seamlessly transition. If the grid goes down, it transitions straight from the grid that disconnects from there and actually will cover the critical loads, which I've got some diagrams at the end that kind of just wrap this up that show how that makes sense. Often the inverter system necessary in a battery-based system can also act as a temporary signal in order to keep solar production going and giving a customer the ability to charge their batteries during an outage. So I mentioned already, when your grid goes down, your grid tied PV only, you do not have access to that solar production anymore. So you can't use that. Even if the sun's out, just because you didn't store it, you still can't use it. The PV array, the solar panels, they are turned off in that situation. When you have the ability to put this battery-based inverter in line, it can actually act as that grid frequency basically and allow for the solar panels to produce. So you're using battery now, and you're able to charge the battery and use PV production. So it's kind of a win-win there as far as, more ability off grid. You don't just have the battery in these cases, you also have the PV production. So you're kind of a little bit of an island there. You're self-consuming, and you're a little bit more resilient in an outage situation. So I think, great example of this is I'm here in Colorado, and we oftentimes get, a big storm that comes through followed by an extremely sunny day. Maybe the snow gets really wet, power lines go down. This is a great time to have a PV and battery-based system. Now you can generate off the sun while, might be weeks before the actual electricity company comes out and fixes that power line. So you have the ability to self-consume and generate. A battery system adds the ability to self-consume power generated by storing it until the customer has a need for it, while also not taking away from the ability to sell power to the grid for credit, meaning that you can basically use your power generated when you have added in a battery. And if you don't have solar, you still have that ability to use that battery when you want. You can charge it off the grid, and you can wait until a certain time of day to discharge it, as most people do with time of use. Some systems are even compatible on financial safety from increasing rates and demand charges such as peak load and time of use. What I mean by that is if you have a large enough system where you are basically net zero, you're not using any utility, maybe you're just paying a hookup fee or something like that, you really have now protected yourself from rising utility costs. And it's not nearly as much of a trouble when the utility company says, I know my utility company here actually just raised our rates pretty significantly. I think like 40%. So, when you have that generation source where you're not reliant on the grid power, you're mostly just using batteries and solar, you have some safety there against those increasing rates. Solar with storage, again, what is a distributed asset? A distributed asset in the context of this presentation is referring to a battery-based system. This can include the production and storage. A distributed asset has numerous benefits for the owner, as mentioned in the previous slide, however, can also build resiliency on a larger scale. I mean that on a grid scale, on helping your neighbors kind of scale. That's what we're talking about here. Cutting down on grid reliance, the ability for reactive power, actually pushing back to the grid for a use where maybe you have the ability to actually boast the grid's kind of own resiliency by providing a generation source and providing reactive power. Environmental impact, obviously, we can significantly cut that down when we're self-generating and self-consuming. I think I often hear one of the biggest arguments that come with buying an electric car. How do I, I'm still charging off of the current electrical grid. Well, this is a great way to not do that. Now, if you've got solar and batteries, you can charge your electric car from your own production source. The ability to know your energy will be available during outages and building security. So really, again, we're talking about like those events where like the Texas outages where they're just losing power for really a long time. These are dangerous situations. These are situations where we really need to have that kind of safety and security. And we can, by putting batteries in place, and definitely by putting, batteries, solar, maybe even just a generator, batteries and solar, all three, you build a very big resiliency in your own home that allows for you not to worry when these big events come through. So on a little bit more technical term, adding storage to a new grid-tied PV system, so new and existing. So kind of some very basic key definitions here. I won't go too far into this. If you're interested in AC and versus DC coupling, I would recommend checking out one of my trainings on it. I've got a whole training regarding AC and DC coupling specifically. It's a bit of a bigger topic. For this presentation, we're talking about AC coupling. PV power is immediately inverted to AC power before reaching loads or battery-based inverter. From there, power can either go directly to loads, grid, as AC power to be converted back to DC to charge the batteries. DC coupling, DC power from PV array will, with charging regulations in order to charge the battery bank before ever being inverted to AC power for loads. Critical loads panel, often called a backup panel, just an additional AC panel added to the home where you put certain loads on it that you want powered during an outage. And frequency shifting, which I don't think we'll really get into much, but a mechanism used by the battery-based inverter to curtail and operate PV production during grid outages. So I'll kind of touch on these, but there's actually some more slides to show these kind of basic situations here. But AC coupling, we've got the panels hooked up to microinverters here, going through a sub panel to the battery-based inverters and batteries, out to a main, out to the utility. Whereas here we kind of have the DC coupled system, PV not being inverted, going straight through a charge controller to the batteries out of the inverter, could be going both to the critical loads or to the main loads in the utility panel. All right, so as far as adding storage to a grid-tied PV system, SimpliPhi offers many solutions for this. They can be utilized for adding a battery to an existing PV system. So when I say existing, we're typically talking about a grid-tied system. Maybe a customer added just a grid-tied PV system. Now they want to go back and add a battery-based system. Some installers may choose to purchase the batteries and inverter not as an all-in-one, but we do offer all-in-one solutions. If you don't purchase an all-in-one, you have a little bit more flexibility regarding sizing and what loads can actually be backed up. And it can actually oftentimes cut down on costs, but we do offer the ESS solution like you see here, the access unit. This definitely cuts down installation time. It's a great choice for installers just getting started with storage, as a lot of the wiring and programming is already done. It is NEMA 3R rated for outdoor installations, and it's great. Either one of these solutions. Looking at time of use, which I talked a lot about, I just wanted to this is a bit of a side note here, but when using time of use, I always recommend going DC coupled, as when you're using AC coupled systems, like adding storage to an existing grid tied system, the time of use set points are not always accessible. So you might be using something like a grid use timer instead of time of use, which basically just says, don't use the grid during these times instead of discharge the battery to the loads during this time. And that's a little bit of I jumped over that one very quick. If you are kind of curious more about that, I'm happy to touch on it later. Okay, so just some basic diagrams. Here we have a grid type PV system design. So basically, as I mentioned, we have panels, we have our microinverters. Let's call this either a combiner, or in this case, we can call this a sub panel that's already put in. So just an AC, just to be used as an AC combiner, and the main panel going out to the grid. So all PV production, it might go to the loads just by proxy as it goes, through the loads panels, but it's not that the loads are calling this production to happen. Any excess goes straight to the grid and is sold back to the utility. When we put a battery system in place, so here we put an access right in place here. And if we kind of look at this, basically now we have the ability to disconnect from here when the grid goes down, and we can cover these main loads. We can also bring back online this PV system to charge the batteries during this outage. Same thing if we're just maybe, adding our own a la carte pieces here. So maybe we have a different inverter here with the batteries hooked up. Same thing though, disconnects here. And now we can cover the critical loads panel, bring back online the PV for self production. So adding storage and PV, and what I mean by that is adding storage and PV at the same time. So when adding storage and PV to a new system, it often can be a benefit of the customer considering DC coupled option. Basically, this allows for better utilization of features like time of use and peak shaving, charging from the charge controller versus the internal charger of the inverter being basically converted from the AC already produced on the roof, provides greater efficiency and more dynamic use of the PV system. Charging is not interrupted when the grid goes down at all, as it's already on that DC side of things. The system can still sell back to grid as an AC coupled system would. It's no different there. Self-consumption can be used more seamlessly, even when the grid is still present. And another big thing is that if you install both the solar panels and the batteries at the same time, you are actually eligible for the ITC, the federal tax credit related to solar production. You can actually apply the battery to that as well, if 75% charged from renewables. So that's a huge benefit there as well, as we can actually take off a significant amount of cost if putting it all together at the same time. As far as what's been put in infrastructure wise in the United States, definitely there's a lot of grid tied PV systems that don't have batteries. It's kind of before the time of putting batteries on residents, definitely grid tied residents. So now we are seeing a lot of retrofits. In that case, we don't use this method of DC coupling, we would use AC coupling. But if you are starting from scratch, you've got a customer that just says, hey, I want both right out of the gate, this is a great way to do it. So DC coupled system, we might have something like, so we have the panels here. This could be a DC optimizer just on a panel level going to the connection with the batteries and the inverter. And then again, we still can go out to the main panel and to the utility or out to the critical loads panel. Same functionality when the grid goes down, when we're talking about resiliency, this disconnects and we can cover these critical loads. So I know there's a lot to kind of push into one little presentation here, but really this is just to kind of talk about the resiliency. I think around these times of year, we definitely have a lot more weather events, and we have a lot more customers looking at why it makes sense to go with a battery-based system. I think there's a big stigma around just going with a PV system. So it's definitely kind of important to show the advantages to adding in a battery-based system and how to do that. So, looking at the financial analysis when we're talking about both covering your own safety, but also looking at finances regarding TOU, peak shaving, self-consumption. Maybe you have an electric car that you're charging. There's definitely kind of the two-sided coin here when looking at, I really want a battery for safety, but I also, I'm looking at the cost that's high. We can look at some of these financial incentives as well around these systems. All right, on a little last note, I'm just going to put a plug in for our own SimpliPhi Elite Installer Qualification Program. If you are an installer that's already installing our batteries, I would definitely recommend signing up for this program. It takes about 10 minutes. You'll end up on our where to buy map. You'll end up on our newsletter. And we have some pretty cool incentive programs coming down the pipe very soon regarding this program that will be for IQ installers. Not a requirement to install our batteries, but an added benefit for anyone that wants to install our batteries. So again, follow the link here, super easy, takes about 10 minutes. If you've already installed one of our battery systems, I would absolutely recommend hopping on and joining that. It's super easy. All right, I know that was quick and easy. This one always is, but I will jump in. If you have any questions, I see maybe one question here in the Q&A, but if you have any last minute questions, please let me know and just jump in there in that Q&A. The question we have here is, can you add an automatic transfer switch between the meter and the main panel and have the whole house be used as a critical loads panel? Good question. Yes, you can. I don't recommend it. There's an easier method to do it. So it just depends on the size of the main loads panel. So let's say the inverter output is enough to cover that main loads or the entire house's loads. Then instead of actually putting that ATS between the utility and the main, I would actually just recommend moving all of the loads over to a sub panel, or even switching out so that the main is the sub panel. So as long as it's on the downstream of the AC output of the inverter, it would cover all of those loads as critical loads. I put that in quotation. If you don't want to go that method, yes, we can do the ATS between the meter and the main panel. It just takes a little bit more rework, and you have to enable certain functions within the inverter, such as sell when the grid is down. Awesome. Well, it looks like no other questions. My email address right there, training@simpliphipower.com. Any other questions or inquiries into our IQ program, feel free to shoot any messages over there. All right. Thank you, everybody.